interpret this now to see what we are going to have. Let me first move it up. I will see H3 here. Alright, now I want to first of all look at the rules used when naming organic compounds. Now we're going to start from alkanes, then we'll go to alkenes, alkynes, and the rest. Now, introduction. The names of the straight chain saturated compounds, remember I told you guys that alkanes are saturated because they have single bonds. Saturated compound up to 12 carbon atoms are should be, yeah, we have already done that. That is homologous series we did. Now, remember I told you guys that if an alkane loses one hydrogen, it will turn to what? Alkyl. So take note of that. It's very, very important. Now, there are a few common branch constituents you should memorize. Which you should memorize? These are, you can see them, those isopropyl we did before. You can see them. Those isopropyl, sec-butyl, tet-butyl, then isobutyl. We have already done those ones. So you take note of them. It's very, very important. Now, here is a sample list of rules to follow. Some examples are given at the end of the list. So we are going to do a lot of examples. Don't worry about the examples. Let's just look at the rules. Rule 1. Identify the longest continuous carbon chain. This is called the parent chain. Now the first rule is for you to identify the longest continuous chain. That is the longest carbon chain there. And that will be the parent chain. Parent chain means the one that will be the something like the main name of that compound, because we are going to have so many substituents inside. So all those substituents, we just call them out. Then before we give our main name. Then rule 2. Rule 2. Identify all of the substituents that is group independent from parent chain. Now, what is the meaning of substituent? It means after you have identified your parent chain, that is the longest chain there, then the next thing is for you to now check for those groups that are not along the chain, but they are just attached to the chain. They are called substituents. That's what we call them. So you have identified them. Then rule 3. Rule 3. Number the carbons of the parent chain from the ends that give the substituents the lowest number. So you are going to number all the carbons in the parent chain only. Then we don't use to number substituents. Number substituents. Take note of that. We only number the carbons along the parent chain only. So as you have numbered the carbon, then you will pick the numbering that will give the substituents the lowest numbers. Take note. For example, now let's say we numbered from any end, because we are going to have so many ends there. Then when we number from one end, the substituent are having, maybe we have two substituents at number 5 and 6 carbon. Then we number from the other end, we have a substituent at number 3 and 4. 3 and 4 is lower than 5 and 6, so pick the lowest number. That's what we are trying to say. Then when comparing a series of numbers, the series that is lowest, that is the series that is the lowest, is the one which contains the lowest number at the occasion of the first difference. Now you pick lowest number. That's what they are still saying. If two or more side chains are in equivalent position, assign the lowest number to the one which will come first in the name. Take care of that. Then number 4. If the same substituents occur more than once, the location of each point which the substituents occurs is given. Location means where is it located? Is it number 1 carbon, number 2, number 3, number 4? That is the meaning of location. So if I have maybe same substituent now, same means, let's say I have 3 chlorine, 3 chlorine present, or 3 methyl or 3 alkyl group present. So the same thing, they should be maybe say 3 methyl present in the same compound. I'll first of all identify the location in which they are. Let's say one of them is in carbon 1, the other one is in carbon 2, the other one is in carbon 3. So that's what they are saying. You locate, you just need that this one is in carbon 1. You first of all take state their location. Then the next thing, the location of each point in which the substituent occur is given. In addition, the number of times the substituent group occur is indicated by prefix di, tri, tetra, etc. If it occurs, let's say 2 times, we use di because di means 2. If it occurs 3 times, you use tri. If it occurs 4 times, tetra, and so on. Then number 5. If there are 2 or more different substituents, they are listed in alphabetical order using the base name. For example, now let's say we have ethyl and methyl. E and M, which one will come first in the alphabet? E will come first. So you list, if you want to list the name of the compound, start with that ethyl because E will come before M. That's what they're trying to say there. Then the prefix which is used, okay. Alphabetical order using the base name without prefix, like ignore prefix. Don't include their prefix. The only prefix that is used is the iso prefix. So the only prefix which is used when putting the substituents in alphabet order, alphabetical order, is iso. That is the iso prefix, like isopropyl, isobutyl. So you're going to take note of that I. That will be I. Then others like sec and tet are not used in determining alphabetical order except you want to compare them with themselves. For example, now you want to compare sec and tet. Let's say we have sec butyl and tet butyl present. And you say which one are we going to call first? Then you now call, let's say, X and T, which one will come first in the alphabet. Then you call the one that will come first in the alphabet. That is the thing they are trying to say there. Then number 6. Let's number 6. If chains of equal length are competing for selection as the parent chain, then the choice goes in the series. For example, now let's say we counted. When we were counting, we discovered that we have like 3 chains, 3 different chains that have the same number of carbon atom, equal length. Which one are we going to choose inside? Look at the one you are going to choose. Number 1, number A. The chain which has the greatest number of side chains. The first of all, check which of the chain has greatest number of substituents. That's the first one. Then number 2, the chain whose substituents have the lowest numbers. The chains whose substituents, after you have counted it, substituent will give you lowest number. Lowest numbers means all those 1, 3, 4, 1, 5, 6. It's not that the substituents are lower in something like we say you want to count substituents, so you are not counting. Numbering, when you number them, the one that will give you the lowest numbering. That's what they are trying to say. Then the chain having the greatest number of carbon atoms in the smaller side chain. Then the chain having the least branch chain. All of them, they are still working something like to harmonize each other. So the chain having the greatest number of carbon atoms in the smaller side chain, you also consider that. Then the chain having the least branch chain. The chain having the least branch chain is even the same thing as the chain which has the greatest number of side chains, because you are not going to consider the little side chains that will be there. Instead of it to just say, let's pick a very big side chain that will have so many branches. So that's what they are trying to say there. Then number 7. A cyclic ring hydrocarbon is designated by the prefix cyclo, which appears directly in front of the base name. For example, what they are trying to say here is, let's say we have, let's say, propane, butane, hexane, heptane. In terms of now cyclic, let's say we have a cyclic compound and we have 6 carbon atoms. For you to just say hexane, you say cyclohexane. You better mention cyclo before calling any cyclic compound for alkanes. Although for alkenes and alkynes still follow. For alkenes, that you don't say, like say cyclohexene. For alkynes, you don't say cyclohexane. That's how it is. So in summary, the name of compound is written out with the substituents in alphabetical order, followed by the base name derived from the numbers of carbon in the parent chain. Commas are used between numbers and dashes are used between letters and alphabet. There are no spaces in the numbering. They are just trying to summarize it. That the name you are going to choose in the compound will be what? The longest continuous chain there. And if you want to number the substituents, number them in alphabetical way, alphabetical order. And if you want to write, let's say you have to write 3 and 2 at the same time, separate them with comma. If you want to write two numbers at the same time, separate them with comma, two numerals at the same time, or 3 or 4. If you want to write if you want to write numerals at the same time, separate them with commas. Then if you want to write numeral and alphabet, if you want to write alphabet and numeral, or let's say letters and numeral, you separate them with either hyphen or dash. So let's look at these examples now. We have some examples here. Let's look at these examples. Let's just look at them one after the other so that you see them. Now look at this example now. This example, look at this one. If you check, let's say we are counting from left to right. We're going to have CH3, CH, CH2, CH, CH2, CH3. So after you count from left to right, now you're going to have 1, 2. The second carbon have CH3 attached to it. 3, 4. The fourth carbon also have CH2, CH3 attached to it. 5, 6. Now, we have 6 carbon atom in the longest chain there. So that means it's hexane. That is the parent name. Then, although I'm not going to be explaining my own like this, I'm going to use my board to do it. I'm not going to be using this one. I'm going to use board to explain my own. So you guys should just try and get this one yourselves. I just want to show you what they mean by hyphen and dash. I will explain my own in my own board. So when they write for ethyl first, why do they write ethyl before methyl? Because E will come before M in the alphabet. You check when between that 4 and E, they separated it with an hyphen. Check. Between that 4 and E, they separated with an hyphen. Between that L is YL. Between that L and 2, separated with a hyphen. Between that 2 and M, separated with hyphen. Before you write alphabet and number, you must separate them with hyphen. That's what I'm trying to tell you now. The name of the compound will be 2-ethyl, 2-methyl hexane. If we look at this long one, this long one is 2,2,5 triethyl, then 4-propyl heptane. Try and see if you can number this one. Number this one very well, although they have already numbered it in a way. So it's 2,2,5 trimethyl, 4-propyl heptane. It's a very simple thing. It's just a straight chain. Although we're having two chains competing for selection here, but we pick the chain that have the largest number of side chains. Try and check it very well. You discover that the number 1 to 7, the one that is lying something like horizontally, number 1 to 7, that is a straight chain. There's also another one, number 1 to 7, that is curved. That is 5 prime, 6 prime, 7 prime. That is a curved. Now, if you consider that curve, you discover that we have how many side chain? 1, 2, 3. Then if you consider the other one, we have 1, 2, 3, 4 side chain, which is the straight one, which you have the least branch chain. You have to choose the one that have the highest number of branch chain. They have the highest number of side chains with the least branch chains. So that's why we don't choose that option 2. So that's how the thing is. So let's look at more questions before we go into other rules. Look at more questions. So just try and see if you can name all these ones, the little ones. Although I'm still going to show you guys how to do it. Just what you can do here. Just what you can do. All right, let's say we have this compound, number 1. So we have CH3. So let's start from this small question. Small question. So take note of this. Could you take note of this stuff? Something like this. Let me just be very careful with what I'm doing before we go and be doing another thing. Something like this. Anything that looks like square is called cyclobutane. The one that looks like triangle is called without multiple bonds, so a single bond all through. It's called triangle is cyclopentane, cyclopropane. Triangle is cyclopropane. I just want to ensure that the triangle is following cyclopropane. Then this one I'll have five-sided shapes. I'll have five-sided shapes. Let me just draw it like this. Just like this. Like this. This one have five-sided shape. This one is cyclopentane. Six-sided shape. Cyclohexane. So that's how we name all these ones. Before you just six-sided, seven-sided, cycloheptane. 50-sided though, you call cyclo, but you call number 50. The one we did before in homologous series. So let's name this one now. So we're going to have 1. So you start counting from, you don't count, you may count like this, 1, 2, 3. You may count like this, 1, 2, 3. Maybe you count like this, 1, anyhow you like. But after all the countings, this CH3 now is not part of this cyclo. And if you want to compare straight chain and cyclic, you pick the one that have the that is greatest number of carbon atoms. We have 3 carbon atoms in this cyclo. This one is already cyclopropane. We have 3 carbon atoms here. This one have just 1. That would be a substituent. So you count so that the substituent will have the lowest number. And if you want to count so that the substituent will have lowest number, it must be number 1. It must be the number 1 carbon. So you must give that number 1 carbon. So if I want to number now, I may just say number 1. Carbon will be here. Number 2. Then number 3. I can decide to number it like that. I may even decide to number it this way. Number 1, number 2, number 3. So the name will be 1. Then what is the name of this substituent? That is ethyl. 1 ethyl. No, methyl, not ethyl. Ethyl is the one that have CH2, CH3. So we have 1 methyl. Not methyl, no. 1 methyl. Then look at this. What is the name of this one? Cyclopropane. So this is the name of this compound. 1 methyl cyclopropane. So that is all for that. Now let's look at another question. Look at another one. Let's have C, 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 C. We have C here. Yes, we have C here. Now let's try this one now. Let's try this one. Please, this is how I'll be writing my own. This one's supposed to be CH3. 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 This one will be CH. This one will be CH2. This one will be CH. But I cannot be writing all the H because of the space I'm using here. Please bear with me. This is how I'll be writing my own. Please just ensure you bear with me. Now, if you want to count now, we can count from. Remember, I told you guys the first thing you do. What's the row 1 again? Who can remember the row 1? Can you remember the row 1? Identify the longest carbon chain as the parent name. Which one is the longest here? Without even a blind man will know that this one will be the longest. Whether you count from anywhere, or this will be the longest, or this will be the longest. So you see, I have 3 longest chain there. So if you want to count now, you count from anyone you like. All of the 3 of them are the same. 3 of them are the same. 3 of them are the same thing. So I'm just going to pick this one. I'm going to pick this one. So that will give me. So that is one I'm identifying now. Now after I've identified that, then the one that are not along this chain will be called substituents. So please take note of this. Something like this is called ethyl. Something like this. Something like this is called methyl. In this place now that you are seeing here. Please take note, it's very, very important. So this one now becomes a substituent. This one becomes a substituent. Why? Because they are not along, they are not with the parent chain, they are just attached. Anything attached to this parent chain will become a substituent. See, I'm already drawing house. Then the next thing, you start numbering. You go to number 1, 2, 3, 4, 5. Or you will number it this way: 1, 2, 3, 4, 5. Now, which of the numbering, which of these two numbering are we going to use? Now we're going to take the one that will give these two substituents the lowest numbers. Now let's check this first one that might move this way. Let's check that first one to see. We're going to have 2. I tell you that this one means what? Methyl. We're going to have 2 methyl here, then 4. We're going to have 2, then 4. If you move this way, then if you move this other way, we're going to have 2 here. That is 2. Then we have 4 here and 4. See, 2, 4, 2, 4. Both of them will be the same thing. So you can move from either way you like. You still have the same answer. So that this one is simple enough. We call this one simple enough. We'll call it simple enough. So we are going to, let's just move like this: 1, 2, 3, 4, 5. We're going to move like that. So we're going to have, check, this and this are the same. So if you want to name, I told you, when you have two same substituents occurring more than once. So what is the parent name first? Let me first give the parent name now. The parent name is number 5, which is what? Parent name will be pentane. That is the parent name. Pentane. Pentane. That's the parent name. Pentane. Pentane is the parent name. So the next thing now, since we have gotten the parent name now, let's give the general name to the compound now to see what we are going to have. Now let's what we are going to do now, let us first of all give the position of these ones before we start naming. Now the rule said if we have two the same substituent of occurring more than once, first of all state their position. What is the position of this one? That's the first thing. What is the position of this one? Don't go and start from 4. 2 is lesser than 4. So you start from this 2. What is the position of this one? We have 2 for the first one. Then what is the position of this one? We have 4. So between the 2 and 4 now, you separate them with comma. Remember I told you that. Separate numbers with what? Comma. Then before you write number now, before you write alphabet now, you separate this number from the alphabet by hyphen. Then how many of this group do you have? We have this one 1, we have this other one 2. We have 2 of them. This one is located at number 2. This one is number 2. This one is number 4. So because we have 2, I will say die. That is for 2. And what is the name of the compound? The name of this kind of compound, this one, is what? Methyl. Dimethyl. And what's the parent name? 5, which is pentyl. Pentane, not pentyl. Pentane, because this one is not losing any hydrogen. So that is 2,4-dimethyl pentane. That is the name of this compound. So it's as simple as that. Just so you follow. That is the major thing. Just follow the rules. Then practice more. Just practice and practice. Yeah. Let's look at more. We are going to do more questions now. Now let's look at this. Right here, I'll write my own just carbon. I'll show just the carbons. 1, 2, 2, 3. Then let's say we have 1 carbon here, 1 carbon here, 1 carbon here. So let's look at the name of this one now. The first thing is to identify the longest chain. That's the first thing. Remember, the first thing is to identify what? The longest chain. So let us identify the longest chain now. Now this one is still having this one as the longest chain. Check. This is still the longest chain. So we have to check for this as well. That will not be the longest chain. So I have 1, 2, 3, 4, 5, 6 carbon. I have 1, 2, 3, 4, 5, 6, 7 carbons. 1, 1, 2, 3, 4, 5. That's just 5. You try to check this one now. That'll be just 5. 1, 2, 3, 4, 5. So this straight chain still have the long. It's not that the thing must be straight. Take note of that. Must not be straight to take note of that. It's just unfortunate that it's like this for these two cases we have done so far. So that's the longest chain, which is this. So just let us identify it first. So anything not with this one now becomes a what? A substituent. So this one now becomes a substituent. A substituent. We have 3 substituents here. So this and this are the same. Then this one is odd from it. So what is the name of this one? Remember, I already told you before. This one is what? Something like this. What is the name of something like this? What is the name of that? See, this is called ethane. Then if this ethane now loses one hydrogen, it become ethyl. That is all. Take note of that. We're supposed to know these multiple things. We have already explained this one. This one now, something like this. In naming, this one is carbon. Supposed to have in organic compound, supposed to take this shape, which is in arcane. In arcane, we are doing arcane series now. Something like this in arcane is called methane, because there's hydrogen here, hydrogen here, hydrogen here, hydrogen here. But we don't need to show the hydrogen. I tell you, I will not be showing the hydrogen. So if I give anything a dash like this, for example, now if I give it a dash, it means one hydrogen is living there. So if hydrogen leave methane, it become methyl. That's what I'm just doing. I'm just using shorthand for this because of the spaces we have in here. If I want to write it out, obviously, look at the way I'm going to write it. I'll write CH3, CH3, that's CH2, CH2, CH2. Then we have space C, 1, 2, 3, 4, 5, C, 1, 2, 3, 4, 5, 6. See, it's already, the space is already finished. CH3. See, there's no space again. There's no space to write. That's why I don't write everything out. So this C was not having something like this. So let me just bring this one here. So let me bring this one here. CH2. This one will be CH3. CH3. Then the other one was attached to this one. So that one will lose one. If I add one bond to this now, I will remove one hydrogen from this place. So I'm going to remove one hydrogen from here. I'm going to remove one hydrogen. We have only one left there in that place. That's how we rule here. So this one have CH. Then that is CH2. Then CH3. This is the other way to write that first compound I drawn before. So I've already drawn it using just carbon only. Now I hope this one is very clear. I said we have 1, 2, 3, 4. These are okay. Let me just forget about the numbering. I want to identify parent name first. I say this is our parent name. This is the parent chain. This one. This is the parent chain. And it's 7. It's having 7 atoms. That is heptane. That's heptane. That's heptane. Then what about the substituents? We have a substituent here. We have a substituent here. We also have substituent here. Now this one is called methyl. This one is called ethyl. Now let's number it to see. We have 1, 2, 3, 4, 5, 6, 7. That is one option to number this chain. Another option is 1, 2, 3, 4, 5, 6, 7. That's another option. So let's pick this first option. Let's pick this first one. This first option to see what we're going to have. If we pick that first option, we're going to have 1, 2, 3, 4. This ethyl will be having 4. We have 4. Then we have 3, for these two. 3, 3. Not even 3 self. It's not 3. It's 5. Look at this. 5 for these two. That's 5, 5. That's what I'm going to have. Then if we take this one, then if we pick this one, this order, we want to name it from right to left. We're going to have this one in number 3. That will be 3. We have 3, 3 for the first two. So will be number 4 and 4. Now let's check. 4, 5, 5 and 3, 3, 4. Which one is lower? This one is lower. So I'm going to go with that way. So I'm going to go with that. Let me check if I can delete so many of these things. Let me delete some of them so that we'll have enough space to do anything we want to do here. This one out. Then let me just repair it. Let's see H2, H3. Let's see H3. This one is CH. And I think is so we're going to let me just use only carbon now. I hope if I use only carbon now, you're able to get. Let me just use the carbon so that I think will be very clear. So let me just use only carbon out. 1, 2, 3, 3, 4, 5, 6, 7. We have 1, 2, 1, 2. This is what we have. This is what we are having. So this one is very clear now. So we can explain this one in a very simple way. So remember, this is the stuff we are taking, and our order of numbering is like this. So numbering from here to here: 1, 2, 3, 4, 5, 6, 7. Remember, heptane is our parent name. So let's call the substituents now to see. Let's call out the substituents. Let me call out the substituent now to see. Let me give a little space here. I'll see a space to write the name. So let's call out the substituents. Let's call out the substituent first. So we're going to have, now, remember we have 3 for these two carbon, this one and this. Then we have 4 for this other substituent here. So we have ethyl. This one is ethyl. This one is ethyl. Then this other one is this one is methyl, as well as this one as well as this still methyl. So E and M, which one will come first? Because I want to start naming now. Which one will I call? Which one will come first alphabetically? E will come first. So I'm going to start from that E. So if I call that E, I first of all call the position of the E. So what is the position of that ethyl? 4. So I have 4 ethyl. That's all. Then I'll go back to this methyl now. What's the position of this methyl? Number 3. Then I have, if I write the material, I first separate with hyphen. 3 for this first one, under 3 for the second one. Then how many did I have? I'm having we have 2 here. Remember I told you if you have more than one substituent, if it's 2 we use di, if it's 3 we use tri. So I'm going to have di methyl. Then continuation, no, the thing is still going to heptane. That'll be the parent name. There's no space here. Don't give space. It's just in a straight line. Don't give space. So we're going to have 4 ethyl, 3 dimethyl heptane. That is the name of that compound we just explained. So let's look at more rules. Then we'll look at more names. After looking at more rules, let's look at more rules now. Alright, for alkyl halide means alkyl and halogens. That's the meaning. Alkyl and halogens. So how do we do it? The halogens are treated as substituents. Take note of that. Just as we do treat all those alkyl as substituents, we do treat halogen as substituents as well. An alkane on an alkyl chain. The halo substituent is considered of equal rank with the alkyl substituents in the numbering of a parent chain. The halogen are represented as follows. Look how we do represent halogen. Let me view so that you see very well. You can see it. That F is fluorine, Cl is chlorine, Br is bromine, then I is iodine. Remember fluorine, chlorine, bromine, iodine. Now in naming organic compound, fluorine will take the name fluoro, chlorine will take the name chloro, bromine will take the name bromo, then iodine will take the name iodo. Let's check this example so you see it. You can see it. In this place now, both methyl and bromine were located in carbon 2. If you count from both ends, we count from left to right. Discover that bromine will be in carbon 3. Then methyl, that CH3 will be in, that is CH3 is methyl, will be in carbon 2. Then if you count from right to left, bromine will be in carbon 2. Then CH3 will be in carbon 3. So they gave higher preference to this what is it called, bromine, which is from halogens. So take note of that. Take note of that. It's like iodine are more something like a little bit higher than this what is it called? All these alkyls. We're now having 2 bromo, 3 methyl butane. The same thing with this. Although this chlorine was located at the central carbon. That's why it was like 3 chloro, 2 methyl pentane. Now let's look at how to name these other ones. The rules for naming all these alkanes and alkynes, all these unsaturated compounds. Let's look at the rules for naming them. Now, alkanes are saturated, then these alkanes and alkynes are unsaturated. Now, double bonds in hydrocarbons are indicated by replacing the suffix "a" with "in." I've already explained that. If there is more than one double bond, take note of this. If there is what? More than one double bond, double, not multiple, just double bond, the suffix is expanded to include a prefix that indicates the number of double bond present. So, for example, now we are now having a diene, that's a diene, a triene. Now, di means how many how many double bond we have there. Tri means how many? Tri is 3, di is 2. Then look at another thing. That A will now show if you have more than one. For example, now let's say we have two double bond in the butane, one at the beginning, then the other one at the end. So if you want to call it, you say 1, and then you mention the last name, which is 3. There is 1, 3. Then you now say buta. You not call it but again. It's supposed to be but 1 in. If it's only 1, it will be but 1 in or butane. But if it's not 2, you not call it buta 1. Then you call the other this, let's say 3, then diene. That's how it is done. That's how it's done. So if this is more than 1, you call it all those buta, propa, then penta, heza, and so on. But if it's only 1, just call it hes. That's all. Then triple suffix is just triple bonds are named in a similar way using the suffix "-ine". The position of the multiple bond within the parent chain is indicated by placing the number of the first carbon of the multiple bond directly to the front of the base name. Directly to the front of what? The base. The position of the multiple bonds with the parent chain is indicated by placing the number of the first carbon on the, take note, first carbon. First carbon means the carbon that will be at the back of that multiple bond, depending on where you are counting from. For example, now, If you are counting from left to right, you know where your back is. If you're counting from your right to left, you know where your back is, because we are going to be using all these things. So if you want to take number of compound, don't go and take carbon. For example, they said indicate by placing the numbers of the first carbon on the multiple bond directly in front of the base. So you pick the carbon at the back of the, that is the carbon you will meet before you get to the bond, not the carbon you will meet after you have passed the bond. No, it's just like the carbon at the back of the bond, or the carbon in which the bond is in front of, something like that. So I don't know if you can get that. You know, if you are at the back of something, it means the stuff is in your front now. If you are at the back of something, it means that thing is in your front. That's what I'm trying to say. So we are talking about the carbon that's at the back of the bond. That means the bond will be in front of the carbon that we are going to take the number of, not the one in front, not the carbon in front of the bond. That be how they will say it. You see it when we are not naming compound. Here is an important list of rules to follow. Rule 1. The parent chain is numbered so that the multiple bonds have the lowest numbers. Double bond and triple bond have priority over alkyl and halo substituents. So whether alkyl group are there or halogens are there, take preference. If you want to number, ensure you give lowest numbering to either double bond or triple bond, because those one has power more than the other ones. Then rule 2. When both double and triple bond are present, number as low as possible are given to double and triple bond, even though this may at times give I a lower number than in. That is, give triple bond a lower number than double bond. I means triple bond, in means double bond. When there is a choice in numbering, the double bond are given the lowest numbers. What I try to say is that, for example, now if double bond and triple bond are competing, maybe they are in the same position. For example, if you count from left to right, double bond will be number 1. From right to left, triple bond will be number 1. Then you will give the lowest number to double bond. But if, for example, now triple bond is number 1 carbon, then double bond is number 2 carbon on the other side, you go give the lowest numbering to triple bond. But if they are both in the same place, you give higher priority to the double bond. Please take note of that. It's very, very important. Although we'll do some examples, you will see. I'll show you some examples here. Let me even show you examples so I see what I'm trying to say. Let me show you some examples. Let me show you examples so I see what I'm going to try to say. Now check this example. This CH3 CH double bond CH double single bond CH, then triple bond CH. Check this one. You can see that they give highest priority to I in there, because they started counting from this right to left. That's why they were having 1 ion, 1 for triple bond, then 3 for in, which is the the double bond. But why? Because this ion is number 1 carbon, then in, if you count from the other side, in will be number 2 carbon. So they are not in the same position. So you give highest priority to the ion. Let's check on that one. Let's check this one so that you see what I'm trying to say. Look at this. Both ion and in, both double bond and triple bond are in number 1 carbon from both ends. So since forget about this, this double bond at the center, even though that one is not there, you still give highest priority to that double bond in the last place, since both of them are in the extreme end. That is what I'm trying to say. So please take note of that. It's very, very important. So let's continue our rules. Now, which rule are we? We are rule 3. When both double and triple bonds are present, the in surface follows the present chain directly, and the I surface follow the in surface. Notice that the E is left off. In instead of, that is N now instead of in. Now what they are trying to say is, look at what they are trying to say in this number 3. If you have double bond and triple bond present in the same compound, what you do, what you do, you will call double bond first before you call triple bond. That's the first one. That's the first thing. Then secondly, you will turn that N-I-E-N-E to E-N. You remove the other E. As far as we have double bond and triple bond. Just like when I was saying just now, I was telling you, if you have more than one double bond, you now use either buta, penta, heza, and so on. I will not come and join because it's now more than one. If you have more than one double bond, I will not come and join the name. The same thing, if you have double bond and triple bond present in the same compound, then don't use E-N-E for the in. You now use E-N for in this time. Don't use E-N-E. But if it's only double bond, you can use E-N-E. But if it's double bond and triple bond, use E-N only. That's what they're trying to say here. That's what they're trying to say. The location of the double bond is indicated before the parent name as before, and the location of the triple bond is or are indicated between the in and the iron surface. See below for examples. For example, now, first of all, state the location and the double bond before you state the location of the triple bond and the iron for triple bond. That's what I try to say there. Then number 4. Number 4. For a branch unsaturated acyclic hydrocarbon. Remember, acyclic means what? Open chain carbon atoms. This one is unsaturated. That means it has multiple bonds. Acyclic that have multiple bonds. Hydrocarbon. The parent chain is the longest carbon chain that contains the maximum number of double and triple bond. You see, remember they use a bold letter to write that maximum number of double and triple bond, because you see some questions in the sense that the longest chain will not have maximum number of double bond and triple bond. So if you have double bond and triple bond or multiple bonds present, if you have multiple bonds present, ensure you pick the chain that has the largest or highest number of multiple bonds. Don't go and be looking for longest chain. No. The parent name must be the longest chain that contains the highest number of what? Multiple bonds. Take note of that. Very, very important. If there are 2 or more chains competing for selection as the present parent chain, that chain with the most multiple bonds, that is the one we consider as parent chain here. Chain with the what? Most multiple bonds. The choice goes to number 1. The chain with the greatest number of carbon atoms. That is, if you have 2 chains with the greatest, that is, if you have 2 chains that have equal number of multiple bonds, now you will choose the one that have greatest number of carbon atom. That's the first one. Then number 2, the dash of carbon atoms being equal, the chain containing the maximum number of double bond. For example, if the number of carbons are equal for both chains, then you will choose the chain having the greatest number of double bond. Take note of that. Having the greatest number of what? Double bond. Then rule 5. If there is a choice in numbering if there is a choice in numbering not previously covered, the parent chain is numbered to give the substituent the lowest numbering. The lowest number as the choice points, at the first point of what? Difference. At the first point of difference. So look at some of these examples. Although I already explained some of these examples here. The one I will just try and explain is this one. If you check this one now, the chain they picked was not the longest chain. It was not the longest chain, but it was the longest chain that have the highest number of multiple bonds. That was why they choose that one as the parent name. That's what I was trying to explain to you just now. So the name was now 3,4-dipropyl, 1,3-hexadiene, 5-ine. You can also call it 3,4-dipropyl, heza-1,3-diene, 5-ine. Because this one is old naming that they are using here. This one is old naming. So also look at this one. Check the name. Although I will explain that one in my board. I will explain as many as I can explain here. I will just explain them using my personal board. Now, let's look at that for alcohols. All those ones for, we have some for alcohols. We have some for alcohols. What you have to do is just to note try your best to note the rules, because there's no time to be mentioning rules again now. There's no time to be mentioning rules. Okay, the hydroxy group is the one that OH means hydroxy group. Take precedence over alkyl group and halogen substituents, as well as double bonds. So halogen, you take preference to all this OH group to any other. That is, if you want to start counting from the place that will give OH group the lowest number, and you use or. If you want to call OH, you call it or. That's what we call it, or. That is the surface. That we call it. Then look at esters are still here. We have so many rules here. Ethers are still here. Although, let me just take this one to another class. We have another class for that. So let's just do the what's it called, the one for this alkenes and alkynes first, so that we know what we are doing. So since we have garnered more knowledge and more rules, let's look at this question now. We have CH2, C, CH2. So we have H here, H. Ensure each carbon has 4 bonds. That's why I'm just doing this to ensure each carbon has 4 bonds attached to hydrogen. So our parent name will be this. This is our parent name. And don't go and call these hydrogens substituents. Hydrogens are not substituents too. All these hydrogens are with the carbons. And all these carbons you are seeing now, they are attached to them. So they are not substituents. So take note of that. I can even write it this way again. I can decide to write it this way. Look at it. CH2, CH, CH, CH2, CH, CH2. 1, 2, 3, 4, 5, 6. Yeah, I have to write it this way. Maybe this is just be the stuff. So we have choice of number 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So there are 2 ways we can number this stuff. There are 2 ways we can number this stuff. So now let's look at the right one now. So this first one, the one that goes this way, is giving us something. Now, if you want to check, if you want to call this double bond now, how do you call this double bond now? Don't go and start from the carbon in the front of it. You take the carbon at the back of it. That's what you do. The carbon at the back of it will take the position of that double bond. Please take note. So it's in carbon 2. You have 2. Then this one, what carbon at the back of this one is in the front of this bond. Carbon at the back is this. So it's number 5. So I'm going to have 2, 5. Then if we take it in this other direction, transfer this. So this one will be 2, 5 for our double bond. Then if we take it this other direction, maybe if we come from here to here, that's from here to here. Then we're going to have this one attached to number 1 carbon, that is 1. This one attached to number 4 carbon. We call the carbon at the back, no carbon at the front. That is 4. So 2, 5 and 1, 4. Which one will come first? Which one is the lowest? The lowest number there is what? Which one is not number there? This one. So we are going to choose this direction. So we'll do away with the other one. Do with the other one. So let's go back and choose our right number now. We're going to have 1, 2, 3, 4, 5, 6. So let's give our name now. So the parent name is 6, which is hexene. Why is it in? Because of the double bond that are there. We have double bonds. It's not alkane. This one is alkane, hexene. Now, how many double bonds we have? We have 2 double bonds. Then 1, 2. So the name is just going to be hexene. The parent name is hexene, but we are still going to call the parent name. So I'm going to have 1, 4. So we're having 1, 4. Since it's now more than 1, remember when the stuff is more than 1, they said when it's more than 1, we'll add A to it, A. So I'm going to have hexadiene. Hexadiene. This one name it also be hexadiene, no. But since it's more than 1, we'll put hexa. This die is telling us that we have 2 of them there. This one they call it one old naming. You can also name it this way. The name is still like this. You can also name it this way. You can also name it this way. Hexa 1, 4 diene. This one is still correct. Also name it this way. So you said that 1, 4 hexadiene or hexa 1, 4 diene. Any of the two are correct. One is old naming, the other one is the new naming we'll use. So we are done with this. Let's look at another beautiful question now. Look at another stuff. Look at another stuff, another lovely stuff. So let's check this. Then let's have C here. We have C here. So what's going to be the name of this one? So see, if I want to start counting, I'm going to start counting from the nearest place to this double bond. Forget about this archive group. The parent name is already identified to be this. This is the parent chain. So this one become a substituent. So become a substituent. So I'm going to start counting from the one closer to that place. Please go out to that, which is here. 1, 2, 3, 4, 5, 6. So this is going to give us 5. Okay, let me just start from here. 5 for this first one, 5 for the second one. And what is the name? Methyl. And how many of them do we have? We have 2 of them. So since we have 2 of them, we're going to denote them with, we have di. That means 2. Dimethyl. And what is the name? Okay, well, let's 6. That is hexene. Think of that. It's very, very important. So the name of this one is 5,5 dimethyl hexene. That's the name of this one. All right, let's consider this compound. We have C. Then this one is double bond, triple bond. So we have this one of C. We have C. Now, if you check this compound very well, the longest chain is this. Because it has 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. That is the longest chain. But are we going to pick that as our parent name? No. Why? Because we are supposed, because this one is now, this compound, because it has multiple bonds, it is unsaturated hydrocarbon. And from the rules we just garnered before, the rules we poked our noses to before, they told us that if we want to select parent chain, we should try as possible way to select the chain with the highest number of multiple bond. With what? Highest number of what? Multiple bond. Is this one having the highest number of multiple bond? No, look at another one. Look at another chain here. Now this one, how many multiple bond do we have here? Just 1. How many multiple bond do we have here? We have 1, 2, 3. So that one will win it because it has highest number of multiple bond, even though it don't have highest number of carbon atom. I don't know if you are following. So you have to know all these rules. Very, very important. So we are going to choose this one now. We are going to choose this because it has the highest number of multiple bonds. So we are going to choose one as our parent name. So since we have multiple triple bond, double bond at extreme end, we'll give preference to double bond. We are going to start from where double bond is. See, both of them are at the extreme end. So we're going to start from there. So this is our, let me first of all rule out our parent name so that this one becomes substituent. So also becomes what? Substituent. So I'm going to have 1, 2, 3, 4, 5, 6. That's what I'm having here. Although this name will be very long. The name will be what? Will be very, very long. So let's try our best to name it, because it's not impossible to name. It's not impossible to name. So let's try our best to see how far we can go. Let's try our best to see how far we can go. So remember this. What is this substituent called? What is substituent called? Remember something like this. C C C. From that first one we did was propane. So if you now lose this one hydrogen, like this one now is attached to this with this line, this one is attached with this line, we'll now call it propyl. So this one now, this guy here is propyl. This substituent, this one is propyl, this one is also propyl. We have 3 carbon atoms losing one hydrogen. It's propyl instead of propane. We don't even have ane as substituent. It's not possible to have ane as substituent. As far as the ane is not a substituent, it will become propyl, alkyl. So take note of that. It's very, very important. So let's start naming now. Let's start naming. So we're going to have 3 for this first one. So we're going to have 3, comma. Then we have 4 for this other one. I'm not going to say 3 propyl, 4 propyl. No. Since both of them are the same, I'm going to call their position at once. Then I will now say, okay, I have 2 of them, which is di. Propyl. Then what's the parent name? The parent name is hers because you have number 6. Propyl. Then you can do it like this. You can just say, you call this in first. You say 1. Then this first double bond is located at this first carbon, that is for 1. This one is located at the number 3rd. 1, 3. Hexadiene. Let me just use small letter. No calculator. I don't think that is a problem. Hexadiene. Then you just use En. Don't use ENE because you have triple bond and double bond. Remember, if we have triple bond and double bond, we just use En. Not ENE. Take note of that. 1, 3 hexadiene. Then we are still going. Then 5 for this one. This triple bond is attached to number 5 carbon. 5 iron, which is YNE. That's for that. YNE. 5 iron. So the name will be this one is old name, 3, 4 dipropyl 1, 3 hexadiene 5 iron. This one is one way to name it. Now let me try and use the new naming now. This is what we are going to have. Now this one is still going to show up. Still going to be 3, 4 dipropyl. Then I will now say hexa. Instead of me to say 1, 3 hexa. No, I will now say hexa. Hexa. Then we have double bond attached to the first carbon. 1. Hexa 1. The other one attached to the third carbon. 3. And who is attached to 1, 3? The in. Remember, double bond is in. Then di. Since I have 2 of them, say di. That means 2. 2 of in. It's supposed to be INE. That is ENE. But because I have triple bond and double bond, I will remove one of the E. I will remove one of the E. I will not include that. I will usually
Ne. I'll use only what? N. Just En. I will not use ENE since I have triple bond and double bond from the rules. Can you still remember? Then we are still going to hexar 1 3 diene, then 5 ine. That will be the name. Because this triple bond is ine. That's why Ne. And it's located at the number 5 carbon. Remember I told you, you don't call carbon at the front. We are coming like this. We are coming this way. This is our direction. So we call the carbon at the back, not the carbon. Call all this carbon at the back, not the carbon at the front of it. That's the position you do give carbon at the back. So this one is at the back of this triple bond is at the back of at the front of this carbon is at the back of this triple bond. That's what I'm trying to explain. So this carbon is 5 at the back of this triple bond. So that's what we are going to call 5 ine. So we also call it 3,4 dipropyl hexar 1 3 diene 5 ine. That is still very, very correct. So let's look at another one. Let's look at something of this nature. So we have CH. Three, CH, 2, CH3, 2, C, CH3. So this one is written in condensed form. So I just want to show you guys how you can interpret something of this nature now. So keep it in your mind. We're going to be interpreting this one now. We're going to be interpreting this. So let's check it. Alright, so let's interpret this now to see what we are going to have. Let me move it up. I will see H3 here. I will see H3 here. CH2 in bracket CH3 then bracket 2 we have CH3. So I'll clean this other one now. Clean this one. So let's write this one out now. Let's write out this, the actual form. So remember we have CH3 here, we have CH3. So let me write it out safe in normal form. We're going to have C, H, 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 H. That's CH3. We have CH2C, H, H. That's CH2. Then look at another CH3 here. I already told you guys in our last video that if you have CH3 inside this place like this, forget about this CH3. Go to this next carbon here and start from here. So I'm going to start from that carbon. Then I'll go to this one. CH3. That is H. CH. H. Then what about this CH3? We have two of it. We have two of this CH3. We have two of it. So I'll put one here. I'll put one CH3 here. I'll put one here. C. H. Okay, let's do it this way. I'll put C. H. 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 I'll put the other one here. C. H. 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 So this is the actual structure here in the normal form, while this other one is condensed form. So this is how you do this. So if you want to write it now just like carbon only without including any other element, I'm just going to write that we have 1, 2, 3, 4, 5. Okay, it's not even up to 5, it's 4. We have 1, 2, 3, 4. We have just 4. So we're going to have something like this. Something like this. I have 1, 2, 3, 4. 1, 2. This is what we have just now. So from here now, we are going to name this compound now. We have 1, 2, 3, 4. So this will give us 2, 2, dimethyl butane. That is the answer. You have 2 for this, another 2 for this. Dimethyl, this. The parent name is what? Is butane. Why did I not start counting from here? 1, 2, 3, 4. If you start from here, this one will be 3. Start from this one will be 2. We take the lowest number. Don't forget that. So let's look at this next one. Look at this next one. Look at this next one. So we have this. I just want to draw so that the thing will at least somehow nice. This one will now attach to something like this. This is what we want to name now. So what will be the name of this compound? So this is our parent name here, which is cyclo. How many sides do we have? We have 1, 2, 3, 4, 5, 6. That is 6 side, and it's a cyclic form. That is cyclohexane. Remember, number 6 is hexane. That's cyclohexane. That's the parent name, cyclohexane. So what is the name of this one? Yeah, that look like cross. That look like cross. What is the name of that? What is the name of this one? That look like cross. That one is actually what we did before. Something like this. I don't know if you can still remember something like this. We did something nice before. We did something nice before. It was like this. We did something like this. What did we call it? We called it tet butyl. Tet what? Butyl. It was like this. You can decide to name it too. You can decide to number it. You can decide to number this one now. This one that looks like this. You have to number this one. This one is the continuous attached to this one is attached to the parent name. You just number 1, then you have 2. That will be 1, 1 dimethyl ethyl. That is, we have 1 for this first one, 1 for this other one, which is this one. Their names are methyl. Then this and this are 2 carbon atoms, which is ethyl. Not ethyl, no, ethyl. Although I'm not going to name it like that, I'm going to name it professionally. Anything like this is called tet butyl. That's what we call it, tet butyl. So if I want to name this compound now, I'm going to name it this way. Tet. You can even say 1 tet. It does not matter. Tet butyl cyclohexane. That's the name. Tet butyl. Which one is the tet butyl? This one there. This one is the tet butyl. Then the parent name is what? Cyclohexane. That is the correct way correct name for this. The other one is just the first one I mentioned is just an alternative name. So take note of that. It's very, very important. So let's look at one more. Look at one more. Let's look at something like this. Something like this. Something like this. Something like this. Yeah, something like this.
I say, what is the name of this compound? What you have to do is start counting from the one closest to this, because this is the parent name is this. Because this one is just 1, 2, 3. This one is just 1, 2, 3 carbon atom. That's what we have there. Actually, in each vertices, you must have a carbon atom there. So that's what we have there. So we have 1, 2, 3, 4, 5. So this one will be 2 cyclopropyl propyl. Then 5 is what? Pentane. So that's the name of this one. 2 cyclopropyl pentane. Take note of that. It's very, very, very important. So what about the name of this one? The name of this stuff here. We have, okay, let me just write this spore. We have CH3 bracket C CH2. Then this one is still going. What is the name of this one? Then this one is still in condensed form. Although I did this one before in my first video. I told you leave this CH3, just leave that one, forget about that. Because this CH3 now is having 3 here. Yes, this is the correct thing. CH3 having 3, then CH2. Since this CH3 is having 3 here, as mean there was nothing there. The only thing was like this, there's no problem. This one is not even correct. Something like this is not even correct. So you put 3 here, say yes, it's correct. So this is what we have now. What's the name of this? Just want to name now. So the first thing is to write it where in this. Just open it. This one is the condensed form now. Open it. Remove all the brackets. That's me of opening. Just open your brackets. So if you want to do it now, there's no carbon here at all. So you forget about this one first that has brackets. Just leave that one. Start from this carbon here, which is we're going to have C. This other one, CH2. Then have this. Then what about this other one? We'll put one here. We'll put one CH3 here. We'll have 3 of them. Then put another one here, CH3. Then put another one here, CH3. So if you want to number this one, I can just say 1, 2, 3. So you say it is 2 dimethyl propyl. You are correct. That is an alternative. That is just an alternative name. The actual name for this compound is you name it this way. Just name everything together, and we call it neopentyl. So we'll call this one neopentyl. As we call it neopentyl. That's the name of this compound. So take note of it. Very, very important. Then let's check if we can do some other stuffs in condensed form. So let's say we have something like this. We have CH3. This is the last one I will explain in condensed form. We have CH3. We have CH2. We have CH3. We have CH. We have CH3. We have CH3 as well. So how are we going to no that one cannot be CH3. We have let me say we have C, then we have CH3 to close it up. We have CH3 to close it up. So how are we going to name this compound now? I'm going to name this one. We have CH3, CH2, CH3, CH, then CH3, everything bracket 2, C, CH3. So I will go to the first thing before you even start naming. First of all, open the bracket where. And how do you open the bracket? You will come, right? This first CH3, you write it as CH3. let me open it very well so that you see it. The first one I did just the same way. We have C, we have H, we have H, we have H. I have the second C, we have H, we have H. Then I told you, since this CH3 is inside, forget about that CH3. Go to the next carbon. We have C, then we have H. Then this CH3 will now come to this place. CH3 will be there. Just move it to become a substituent. Then we move on. Then look at another CH3 here. Just leave that one. Go to this next carbon, which is C. Then this CH3, one will come here, CH3. The other one will go up, CH3. Then the next thing, we have another CH3, C, then H, H, H. So this is how to open the bracket. You open it very well. Don't go and be doing another thing though. When you see CH3 inside a structure, leave it. Go to the next carbon. First of all, write that one out. Then before you start, just make anything other than carbon inside the structure should become a substituent. That's just the thing I will tell you. Because nothing should be along the chain unless you are forming a functional group, like when you have oxygen along the chain, they will now call it acosi, all those methane diethyl, all those ethers. When you now form functional group, as far as non functional group is straight chain leather, but alkanes, we have a CH3 inside should become a substituent. Take note of that, it's very, very important. So let me number this one now. I want to number it. So let me rewrite everything again. Since you have seen it now, let me just rewrite everything again. Rewrite everything that the thing will not be claiming space, so that we can number it. Then this is why this thing is taking time, because I want you guys to understand it very well. That's the major thing. You guys to understand what we are doing here. Understanding is the major thing. Once you understand it, we are already good to go. So I said we are having CH3, this one is CH2, and we have CH and CH3. You can either go up or come down, no problem. Then we have C, CH3, then another one CH3 up. Then we have a C, H3. This is what we're having now. This is what we're having. So this bond can be here, no problem. The bond can be there. So this one is CH2. So that one is CH2. So let me correct that. That's CH2. Sorry about that. That's CH2. That's CH2. So we have CH3, CH2, CH, C. We have this thing there. So if you want to start now, because that the substituents are closer to this end. Check both ends. Substituents are closer to this end. So we're going to start from this place. Start moving from that place. And the parent thing is, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the parent name is 5. It's 5. That's 5. I can see here. I can observe 5. The longest to be the longest chain. So I'm going to pick this one. I just pick this to become the parent chain. Each number, that's 5. I'll start numbering from here. 1, 2, 3, 4, 5. So let me just write it in terms of carbon. Remember, we have 1 in carbon 2. We have the other substituent in carbon 3. I'll have 5 carbon there. So we have 1, 2, 3, 4, 5. We have 1 there. We have another 1 there. 1, 2, 3, 4, 5. So we have 1 here. Another 1 here. Then we're having another 1 here. So this is 1, 2, 3, 4, 5. So the name will be 2 for this first one, another 2 for the second one,
then 3, 3 for this one. That is 2, 2, 3. Then how many do we have? Why am I calling every time I say that? Because they are all the same. Check, they are all the same substituents. That's why I'm calling all of them at the same time. So how many substituents do you have? You have 3. That is try. Try is for what? Try is for 3. Then what is the name of the substituent? Methyl. Try methyl. What is the parent name? Pentane. Not pentane, no, pentane. Pentane. So take note of that. So there's the name 2, 2, 3 try methyl pentane. So take note of that one. It's very, very important. So I've showed you how to expand condensed form now. So let me just do the line method. Something like this. Let's say you have something like this. Now ask what is the name of what is the name for this compound. So you just count from where you have this double bond. Count from where you have this double bond. You will count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. So you just a straight chain. That's normal. It's supposed to be decay. Remember, number 10 is decay. But since we have a double bond here, remember this surface will not change from A to in. So we'll be having decaying. With decaying. That's all. Or deck 1 in. Deck 1 in or deck 1 in. You can also call it like that. It's still very, very good. So I hope you are following. So let me just look at another one. Let me try and look at another one. Let's see if we can do another one like this. Something like this, like this. One, two, three, four, five, six, 7, 8, 9. And I don't want to say it will now be so let's look at this, something like this. If you count from here, now we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. If we count from here, we're going to have 1, 2, 3, 4, 5, 6, 7. So that's not okay. 1, 2, 3, 4, 5, 6, 7. That's not okay. 1, 2, 3, 4, 5, 6, 7. That's not so okay. That's not so okay. You may even see the longest chain that I can see from here. That's how it is. 1, 2, 3, 4, 5, 6, 7. That one is still 7. That is still 7. That's 7. That's 1, 2, 3, 4, 5, 6, 7. That's not okay. That's not okay. So we are just having 7, 7, 7. So because of time, we just pick this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one is 9. We just pick down because of time. I just pick down because of time because that's 9. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be this one will be number 5 because that is one we are taking regards to now. Then I also have 1, 2, 3, 4, 5, 6, 7, 8, 9. We still be number 5. If we count from either this place or from this place, this substituent will be number 5. So there's no thing to bother about. Substituent is in number 5. So let's count from anywhere we like. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 1, 2, 3, 4, 5 is still being 5. Count from each end. So this will give us 5. And what's the name of this compound? What's the name of this one? 5 iso. Remember that is what we call isopropyl. Isopropyl nonane. Remember number 10 is what? Number 10 is nonane.
So this 5 isopropyl nonane. So I will just stop here because of time. Maybe next time we'll continue.